Welcome to lesson 4.1.3, modeling chemical reactions. Remember our video guidelines. Please use headphones, write down anything that is bold and blue, pause, rewind, rewatch if you need to. A chemical equation shows the starting compounds, the reactants on the left, and the final compounds, the products on the right, separated by an arrow. The reactants are the substances that take part in and undergo change in a chemical reaction. The products are the results of the recombination of atoms at the end of a reaction. The yield sign is the arrow that separates the reactants from the products. We formally call it the yield sign. So in this example, we have the combination of water and phosphorus pentaoxide yields phosphoric acid. States of matter are also shown as symbols in chemical equations. The chemical symbols are S for solid, L for liquid, G for gas, and AQ for aqueous, which is simply a substance dissolved in water. These are the parts of the chemical reaction. Please copy this in your notes. So we have the reactants, the yield sign, and then the products, and then you can also see the states of matter here. So let's test your knowledge. What are the reactants in this equation? You should have said FeO3 and H2. They are on the left side of the equation. What state of matter is MgOH2 given in this equation? You should have said aqueous. The AQ told us it was aqueous. Coefficients versus subscripts. Coefficients are the large numbers in front of the substance that describes the total number of molecules. The subscripts are the small numbers that come after an element symbol that describes the number of each atom. So here's how we can see the difference. So if we have H2O, which is water, changing the coefficient changes the total amount, right? So if I put a 2 in front, you can see I have 2 water molecules. But if I put a subscript, that changes the composition and identity of the substance. So it's no longer water. It is now H2O2, which is actually hydrogen peroxide. So let's practice counting some atoms here. We're going to look at the subscripts. So if I look here, there is 1 Na atom, there are 2 carbon atoms, 3 hydrogen, and 2 oxygen. What happens if I have a coefficient and a subscript? This is where you're going to multiply. So you multiply the coefficient by the subscript, and this applies to each element. So for hydrogen, 6 times 2, that means I have 12 hydrogen. For oxygen, there's no subscript, which means there's 1, so 6 times 1 is 6. Again, the coefficient applies to every element. We must balance chemical equations to show the law of conservation of mass, right? So mass cannot be created or destroyed, so the reactants must equal the products in the amount. To balance a chemical equation, you can only use coefficients. Here are the steps to balancing chemical equations. First, count the atoms of each element on both sides of the equation. Start by balancing the smaller side by using coefficients so that the number of atoms of each element is the same on each side. You're going to repeat step 2 until all of the atoms have the same number on both sides of the equation. Let's look at some examples. So here I have N2 plus H2 yields NH3. This is what it would look like on a molecular level, right? So I can tell that it is already not balanced because I have 3 H's on the product side and only 1 N, and 2 N's and 2 H's on the reactant side. So let's start by counting the atoms on both sides. So on this side, there are 2 N's and 2 H's based on the subscript. On the product side, I have 1 N, and 3 H's based on the subscripts. So I'm going to start with the smaller side. So I need the product side N to be 2. So I can only put coefficients. So I'm going to put a 2 coefficient on the line. That 2 coefficient applies to the N and the H. So that's going to change the N to 2. And then I multiply the subscript and the coefficient, so 2 times 3. So that changes the H to 6. It is still not balanced, so I need to go back onto the reactant side and change the H. If I want this to be a 6, what times 2 will give me 6? That is a 3, so I put a 3 coefficient, making it 6. Now it is balanced. Once it's balanced, I'm going to put a 1 on the line that I did not do anything to. Let's look at another example. Okay, so I have MgHCl yields MgCl2 and H. This is what it looks like on the molecular level. Let's count the atoms. On the reactant side, I have 1 Mg, 1 H, and 1 Cl. On the product side, key here, you want to write them in the same order, not in the order they appear in the equation. Write them in the same order so that when you look across to compare, you can clearly see what needs to change. All right, so I have 1 Mg, 2 H's, and 2 Cl's on the product side. So I'm going to start by fixing the reactant side of my hydrogen because I want it to be 2. So what times 1 will give me 2? I'm going to put a 2 coefficient in front of HCl. That changes the H to 2, but it also applies to the Cl, so it changes Cl to 2. And now it is already balanced. So I put 1s on the lines that I didn't do anything to. And this is what it looks like now. So you can see I have 1 Mg on both sides, 2 H's, and 2 Cl's. The last type of reaction that I'm going to show you how to balance are what we call combustion reactions. So combustion reactions are where you have a hydrocarbon, so like CnH, plus oxygen gas, and it always yields carbon dioxide and water. The trick to this is always balance the carbon first, then the hydrogen, and then do the oxygen last. All right, so let's do the same thing. Count the atoms on both sides. On my reactant side, I have 1 carbon, 4 hydrogen, and 2 oxygen. On my product side, I have 1 carbon, 2 hydrogen, and 3 oxygen. So the carbons are already balanced, so I'm going to go to the hydrogens. I need to fix the hydrogen on the product side because it's the smallest. I have 2, I need 4. So what times 2 is going to give me 4? It's going to be 2. Note here, why do I have 3 oxygens? It is because the carbon dioxide has 2 oxygens plus the 1 oxygen in water. So that's how I got 3. So I want the H's to be 4, so I'm going to put a 2 coefficient in front of the H. That changes the hydrogen to 4, but it changes the oxygen to 4, right? Because I had 2 from the carbon dioxide and 2 now from the water. So now I need to go on the product side and change the oxygen to 4. So I want 4, I have 2, 2 times 2 is 4, and your equation is balanced. Go ahead and finish the Nearpod now.